Hello everyone. My name is Sai Emanur. Today I'm going to talk about low-cost, high-quality Raspberry Pi citizen science projects as STEAM motivators. As a part of our presentation, I'm going to present our Purple Daisy STEAM platform. We are going to present how um, open source Raspberry Pi based citizen science projects could be used as motivators for um, STEM education. Um, the agenda for today, I'm going to talk about I'm going to briefly introduce myself and my co-author, my brother Shri, and I'm going to talk about the Purple Daisy platform, the educational opportunities this platform can present, and I'm going to do a brief demo before I wrap things up. I hope you enjoyed today's talk. Thank you. A little bit about myself. I'm a mechatronics engineer by education. I'm currently based in the San Francisco Bay Area, and I currently work for a medical diagnostics company. I'm a citizen science enthusiast, and in my free time, I like to design hardware that enables pursue my interest in citizen science. I work on a lot of these projects with my brother Shri. He works in the medical devices industry, also in the San Francisco Bay Area, and we both worked on this project together. Now, to the uninitiated, a citizen science project refers to participation of citizens in conducting science experiments. So anyone that's interested in learning about their immediate environment can actually start a citizen science project. When it comes to a citizen science project, there are certain requirements. In order to conduct a citizen science project, there are certain requirements. For example, the hardware needs to be reliable. The data collected needs to be of good quality so that we could share the data and analyze it and share it with a wider audience. The experiment that we conduct needs to be replicable. It needs to be cost effective so that we can share it to a wider audience who can further replicate the experiment. And finally, marketability. In order for a project, to make students be interested in a particular citizen science project, it needs to have some attractiveness to it, something unique that the student could grasp from conducting a citizen science experiment. In a typical citizen science experiment, you are recruiting volunteers, you're training them on how to conduct an experiment. You're collecting data, you are analyzing the data, understanding what works in the experiment, and see if it needs further refinement before training your volunteers again for further data collection. A citizen science experiment is typically very volunteer driven and data driven. Now, when there are students in the loop, there is an additional step where we need to collect feedback and evaluate the students' understanding to further enhance the training process. A typical citizen science project should be result oriented, meaning when we are starting a citizen science experiment in a classroom, we need to ensure that the students develop a good understanding of the concept that is going to be taught in the classroom. It must have a positive impact on the society, and it also must produce results that have solid scientific grounding. And like I mentioned before, it has to have that factor that would actually engage students in the classroom. Um, like I mentioned before, most citizen science experiments are designed to include people from all walks of life. A citizen science experiment must demonstrate learning opportunities, and the students should demonstrate some level of understanding after finishing the experiment. And the goal here is to actually motivate students using citizen in STEAM fields, using citizen science experiments as an opportunity. So when it comes to a typical citizen science project, there are several opportunities that are available today. For example, there are low-cost single-board computers like the Raspberry Pi. Because of their inherent nature of their low cost, they are widely available. There are plenty of sensors available due to the advent of low-cost processors, easily available prototyping tools like 3D printers, electronic prototyping platforms, and things like that. And the widespread availability of Bluetooth Wi-Fi options on low-cost hardware are also present a great opportunity to develop low-cost citizen science projects. I want to talk about now. I want to talk about the Purple Daisy STEAM platform that we have designed. When we got started with this project, we wanted to make sure that this is something that is easy to use. It's low cost. We've always wanted this design to be open source, so that people could, just run, copy our design and just run with it when it comes to conducting citizen science experiments. Here is a detailed view of our Purple Daisy STEAM platform. We made it look like a daisy so that it looks appealing and not like a boring electronics board. Our design is centered around the Raspberry Pi RP2350 microcontroller. It has a 4-digit 7-segment display. It has a micro SD card holder for data logging purposes, a buzzer. It has a lightning sensor that can detect lightning in a 15-mile radius. Students can actually add their own sensors if they want. There is an air quality sensor and a soil pH sensor and a temperature sensor which can be used to conduct specific citizen science experiments involving soil pH and like soil temperature. Here is an example of an experiment that you can conduct with our Purple Daisy platform. You can observe hydrangea flowers changing color based on soil pH. Hydrangea plant hydrangea plants flowers, especially the one that's blue, changes color when you add citrus salts to it. So usually it has a blue purplish tint when it's of 1 pH, and when you add citrus salts to it, it can actually develop a pink tint, and that would be a good citizen science experiment to conduct. Other experiments include measuring the pH of tea at home and measuring air quality in your immediate surroundings. Here is a demo of the pH sensor. I'm going to show the Purple Daisy measuring pH using a buffer solution at pH 10. So in this case, it's measuring about 10.35. I apologize for the poor lighting in the video. I had to make some sacrifices because the 7-segment display is too bright, and my camera couldn't necessarily capture the video. In this video, what's happening is that I have connected a pH sensor to the Purple Daisy, and I am measuring the pH of a buffer solution available from a lab supply store. This is a very basic experiment that you could conduct using the Purple Daisy STEAM platform. And I want to highlight one benefit of using the Raspberry Pi RP2350 microcontroller. It's that you can program this microcontroller in MicroPython. Because of the ease of learning Python programming language, MicroPython, which is the flavor of Python, actually enables students to run their own experiments using this hardware, and the barrier to entry is further lowered, which should promote adaptability among students. Here is a detailed cost of all the components for our for the sensors and the hardware that we have used in the project. It comes down to about $240 per unit. This is because we built a very small volume. If we were to build them in larger quantities and perhaps substitute the sensor that we used in our design, we can definitely bring the cost to under $100. But this is a good place to start, and we plan to further scale our project by publishing all the experiments that could be possibly conducted using the Purple Daisy platform, as well as the code samples needed to get started. We hope you found this presentation to be useful. Please do get in touch with us if you have any questions, or if you are interested in promoting, if you are interested in adapting the Purple Daisy platform in your classroom for encouraging your students to get involved in citizen science. Thank you. That's all I had.